is our lesson on how to solve rational equations. So we did something like this a few videos ago where we had problems like this when we did the guess and check using our accelerated math answers. When you look at this one, what you want to do to solve this equation is get rid of the denominators, just like we always have when we have fractions with an equation. The nice thing is that you can multiply the whole equation by the common denominator. So when you look at this denominator, your common denominator is going to be the numbers plus that binomial there. So I have a 28 and a 4. My common denominator between those two numbers is 28. And then I have to keep the x plus 2. So that would be my common denominator for this whole thing. So I'm going to times everything by that. What that does is as I distribute here, I'm going to distribute this here. Think of it as canceling, cross-canceling some things. So when I look, I'm actually going to the 28 and the 28 will cancel. So then I would have 9 times what's left, the x plus 2. Now notice my canceling disappeared because now I have a whole new multiplication. The same thing, the 28's not cancel anymore, gets times by the 3 over x plus 2. So when I go to cancel, I can cross-cancel the x plus 2's. So I end up with 3 times the 28 that's there equals. And then I start from scratch again. I distribute to the 3. So when I look at cross-canceling, my 4 goes into my 28 7 times. So I would have 3 times 7 times x plus 2. So take a look at that, how I did my canceling each time, and what canceled is not showing up there, but what was left. Because if you think of it, this is really 28 times x plus 2 over 1. So I'm just cross-canceling like I do in any multiplication of fractions. So from here, this is a pretty basic problem that I can solve. I would distribute my 9, so I'd get 9x plus 18, and then 3 times 28 is 84. And then this is really 21, right? So I distribute the 21 and get 21x plus 42. When I combine like terms on my left side, I'm going to minus 21x from both sides. I'm also going to minus 102. I like to do this in one step. So then I would have negative 12x equals negative 60. So I get x to be 5. Now here is the only catch for these problems. When I get my answer, I have to make sure it checks and it doesn't make my denominator 0. So look at my original denominators. I don't have to worry about a 0 happening here, but look right here. What would make my x be a 0? Well, if x was equal to negative 2, right? So because I didn't get negative 2 as my answer, I'm good. 5 checks. Because this one doesn't matter, right? There's no x there. But if I would have gotten negative 2 as my answer, I would have no solution to this problem. And this is as far as I could go. I want you guys to try number 2, and then you can check your answer with mine. Can't equal 3, so my answer of x equals negative 45 checks. Number 3 then, before I multiply, notice that I have something in my denominator that I can factor. So I'm going to try and factor right here and get x minus 2, x minus 1. So now my common denominator would be the x minus 2 and the x minus 1. So I'm going to multiply my whole equation by that. Now, I don't want to confuse you here. I just ran out of room. So you should write it like this so you realize it's not a fraction. In fact, I don't even like the way that's written. So we're here. So when I go to distribute this, my x minus 1's would cancel, and I'd have the 4x times x minus 2. And then I'll bring over my minus 5x, and then my x minus 2's will cancel, so I'd have my 5x times x minus 1. And then the really nice thing about my last part is they both cancel, so I'm just left with the 2 that's already there. So as I go ahead and distribute this, I'd have 4x squared minus 8x minus 5x squared plus 5x equals 2. So when I combine like terms, this is what I have. And then I know I'm going to end up having to factor this because I have an x squared and an x. So I'm going to choose to move this stuff to the other side because I don't prefer to factor with a negative x squared. So I would end up with x squared plus 3x plus 2 equals 0. And I'm thinking I should get two answers here, right? Because I have an x squared. So when I factor it, I get x plus 2x plus 1. So I set each factor equal to 0 and solve. So I get x to equal negative 2 and x to equal negative 1. Now my only catch is that I have to go back up and see what would make my denominator be a 0. So when I go up here, I can't have x be a 1 or x be a 2. Either one of those would make my denominator be a 0. Did I get 1 or 2 for my answers? Nope, I got negatives, so I'm good to go. So I'm just going to say x can't equal 1 or 2. That's what I checked, so it works. So like you guys, well, let's do number 4 together actually. Number 4 looks a little confusing because I don't have a denominator here, so I'm going to go ahead and put that over 1. And then here I'm going to factor my difference of 2 squares. Oops, tried to do it wrong again. There we go. So hopefully you see that your common denominator would be r plus 1, r minus 1. So that's what I'm timesing by. Again, write yours side by side. So because my r here has nothing in the denominator to cancel, I have to go ahead and write r plus 1, r minus 1. So both of these. But I know that those FOILed is r squared minus 1, so I'm going to go ahead and write it like that so I don't have to do extra work. And then I have plus r squared minus 5, and both those canceled, didn't they, with my what I'm multiplying by, so that's good. Equals r squared plus r plus 2 times, only the r plus 1's canceled, so times r minus 1. So now, to reduce this equation, I have to go ahead and distribute my r. So I'd have r cubed minus r plus r squared minus 5 equals, and then I'm going to go ahead and distribute to both. So I'd have r cubed minus r squared, distribute to both, plus r squared minus r, distribute to both, plus 2r minus 2. So when I combine like terms on both sides, this one I'm just going to write in descending order. There's nothing to actually combine. Here I would have r cubed, and then my r squareds cancel, plus r minus 2. So I'm going to move everything to one side. And I'm going to do that in one quick step. Minus r cubed minus r plus 2, minus r cubed minus r plus 2. So I end up with r squared minus 2r minus 3 equals 0. So when I factor this, I get r minus 3, r plus 1. So r minus 3 equals 0, which tells me r is 3. R plus 1 equals 0, which tells me r equals negative 1. So before I decide what my answer is, I go all the way back up to my original problem and I look for what r cannot equal. So what would make my denominator be a 0? Well, right here, if r was negative 1 or 1, it doesn't work. And then same thing here, negative 1. So I can't have r be a plus or minus 1. So r cannot equal a plus or minus 1. We'll look at right there. Can't be negative 1, so my only answer that checks is r equals 3. So make sure if you have any questions on this, you let me know tomorrow.